So here we go with chapter 2.5, example 17. Y equals the modulus of f of x and y is equal to f of the modulus of x. So we're looking at sketching these kinds of functions. So the key thing is to remember what the modulus function represents. So we've got this modulus function here, and that basically says make it positive. Well, f of x is the output. So this means that all outputs are positive. So if we look at the graph we're looking at over here, then those outputs are positive anyway, so they remain the same. When the outputs from the function f of x are negative, this section of the graph, they've got to become positive. They get reflected in the x-axis to give positive values. So they get reflected in the x-axis. Right, so reflect any parts where f of x is less than 0 in the x-axis. Okay, and then delete the parts that are below. Okay, secondly, if we now look at our next function, I'm going to undo those so I can use the original graph again. So, if we now look at this one, it's saying the inputs into the function f are positive. Inputs into f are made positive. So if we come back up here, well, the inputs for positive x is this section. So this bit of the graph is completely unchanged because the x values were positive to start with, so the outputs are the same as they would have been. When we put in a negative value, so say -1, we would have to make it positive, so it becomes +1. When we put 1 into the function, we get this value out, and then it gets plotted back underneath. You have the -1, which was our starting value of x. So we started with x as -1, the modulus sign made it +1, we read off a value from the graph, but it gets plotted back underneath -1, our starting x value. So the effect of that, I hope you can see, is that they get a reflection in the y-axis. So the part that was yellow is reflected, and we get a graph reflected across here. So reading through the text, sketch the graph for y for x greater than or equal to 0. There, and then that parts reflect this in the y-axis. Okay. So now we're going to go through that with an example. F of x equals x squared minus 3x minus 10. Well, you can see that the first thing we need to do is know what that graph looks like. So for sketching a graph, we tend to want roots, y-intercept, perhaps they should be in the other order, it doesn't matter hugely as long as you've got both. Turning points. Yeah, it's a quadratic, so they're the key things. Other times we might be looking for asymptotes, etc., etc. Okay, so let's just work through those. Y-intercept, let's do first. Y-intercept. That occurs when x equals 0. So f of 0 is equal to 0 squared minus 3 lots of 0 minus 10. So that's -10. Roots. that's f of x. The output's a naught, so naught equals x squared minus 3x minus 10. Factorise, complete the square, or use the equation, whatever you want to do. X minus 5 times x plus 2, so x equals 5 or negative 2 are my two roots. And then the turning point, we could differentiate and substitute back in. I'm going to quickly complete the square. So f of x equals x minus 3 over 2 squared minus 9 over 4 minus 10 is x minus 3 over 2 squared minus 49 over 4. So my turning point is at 3 over 2, making the bracket here equal to 0. And negative 49 over 4 for the y value. So I can sketch my graph. It's a quadratic. So first of all, it's a positive quadratic, so I'm going to draw the shape. I know I've got two roots at negative 2 and 5, so I can put my x-axis on next. Then I can put on my turning point, which is 3 over 2, negative 49 over 4. So I know my y-axis must go in between the minus 2 and the 3 over 2. So y-axis is going to go in there, y-axis 0, and I know that the y-intercept is negative 10. So let's just label that up. 1 was draw the curve and put on the x-axis. 2 was label the turning point, and 3 was our y-axis and y-intercept in terms of drawing it on. So 1 roots from here, 2 the turning point from here, and 3 the y-axis and the minus 10 from here. Okay, now part B, the modulus of f of x, the modulus of f of x. So the outputs must be positive. So where are my outputs already positive? Here. So those bits of the graph we can draw. And then the bit that's negative is going to need to be reflected. So we're going to get, let's undo, so we're going to get a graph which looks like positive, reflective, positive. And this was at 5, this is at negative 2. This will now be at 10 because of reflecting. And this is still, the x value is 3 over 2, and this is now going to be 49 over 4 from the reflection. X, y, 0. Hope that makes sense. Just rub out that little bit because I don't like the way it's turned over. And the other key things to notice are that these are corners, not smooth curves at the bottom. Okay, part C. We've now got to do y equals f of the modulus of x. So this says that the inputs into the function, the inputs into f, inputs into f are positive. X can be negative, but it gets made positive before it gets put into the function f. So anything where the inputs were positive is unchanged. So we've still got that. So that was at 5, and that piece of graph here is coming straight from here. It's not changed because the x values were positive. So this point down here must still be negative 10. This point here is 3 over 2, 49 over 4 negative. Now, when we start with a negative value, say negative 2, it becomes positive 2 because it's the modulus of negative 2 equals 2. We come down, we read that off the graph, and then it gets printed, plotted back over here. So it's going to do this kind of thing. Okay, so let's do that on here. Reflect it, in effect, in the y-axis. So this point will be minus 5, and this lowest point here will be negative 3 over 2, negative 49 over 4.